Hello everyone, it's me Matthew again, and today we're in the Stacks and Queues module, specifically the make valid string question. So before we get into the question today again, I just want to relay the steps that we went through in the last problem to help us figure out what to do in this question and how to solve it again. So if you recall, the first step was to understand the problem. And what we did in the previous problem was we read the problem statement and we went through each example and also the constraints just to really understand what was going on. And what we understood what was actually happening in the question, we just came up with a solution. Now remember, we don't actually care about what the complexity of this is in terms of time or space yet. We're just going to want to come up with anything, and after we've come up with the solution, then we actually have a third step, which was just to optimize. So once you're done with your solution, you're going to want to see, okay, is there anything I can optimize in terms of time complexity, space complexity? Are there any other data structures that I can use to help my solution become better? So yeah, those are the three steps that we had, and now that we've sort of communicated them, we can get into the statement and figure out what's going on. So step number one, let's understand the problem. So we're given a string str that contains only the characters given here, so only these parentheses. And the string str is valid if each opening bracket is closed by a matching bracket, each bracket is closed in the correct order, and each closing bracket has a corresponding opening bracket. So if it doesn't follow any of these, then the string is invalid. And so what we have to do is, if the string is not valid, then we have to add the minimum number of brackets to make str valid, and then we return the new string. And if the string is already valid, then we just return it. So that seems to make some sense. Let's look at the example test cases. So example one, we're just given this opening parenthesis here, and then and then the output has an opening parenthesis, and then we match that with the closing parenthesis. And the explanation is that the opening parentheses must be closed by a matching closing parenthesis. And this makes sense because we look at the first condition for the problem statement, and it says that each opening bracket is closed by a matching bracket. And the str here didn't have a closing bracket for this initial opening parenthesis, so we just added that, and now the string is valid. And the second example, we have this opening brace which is closed by a parenthesis, but this is actually a violation of the first condition, and so we see that the output matches the brace correctly, and this closing parenthesis has to be opened by the corresponding opening bracket because of the third condition, and we see that this is actually a valid matching of the string. And we just look at the explanation again. The corresponding braces and parentheses were added to make str valid, which makes sense because we just looked at the conditions that were now satisfied. And we also note that there are multiple correct outputs for str. So we see that we could have added the brace and parenthesis in the second or in these two ways as well, and either would have been fine. And then we look at the third example, and the output is the exact same, and the explanation is that str is valid, so we return it. And that makes sense because this opening parenthesis is closed by the corresponding one, and it's also closed in the correct order, and same goes for these braces. And then we look at example 4 and example 5, and we're essentially just doing the same thing and we did in example 1 and 2, where we're opening and closing the parentheses that aren't opening and closed correctly. So once more, we just look at the constraints and we see that there's some sort of limit on the length of the string. So we note that the string is allowed to be empty, so we might want to take note of that for our solution. And then there's just some upper bounds on the length of the actual string. And then it says here that each character in string only contains these characters right here. So we don't have to worry about handling other special characters, which is great. So now that we know what's going on in the problem, we should try and really come up with a solution. So let's just call this solution 1, right? Since we might have some other solutions, it might not be optimal. So what we want to do is find out if a string is invalid, right? Because that's what we want to do. We want to find out if it's invalid. And if it's invalid, then we want to add the parentheses needed to make the string valid. So what we can do is iterate through str, right? And when we're iterating through str, you might note that each string is either going to be of the opening parenthesis kind or a closing parenthesis. So stri is an opening, let's just call it an opening bracket, right? So what are we going to do when we find an opening bracket? Well, the condition here, let's just go through them again. Each opening bracket is closed by a matching bracket. Each bracket is closed in the correct order, and each closing bracket has a corresponding opening bracket. So the first two conditions here actually have to do with when we encounter an opening bracket. So we're going to want to make sure that if we find an opening bracket, find a corresponding closing bracket. And not only that, but we want to make sure that each bracket within these brackets that we just found are closed in the correct order. So make sure brackets within brackets are closed correctly. So essentially what we can do actually, instead of just checking if they're all closed correctly, we're also going to want to check that the brackets within these brackets that we just found are valid themselves. Otherwise, we can have a string like this, right? Where this second parenthesis is being closed, but we have a bracket within this parenthesis which isn't being closed correctly. So we can just say if there's a set of parentheses that are not being closed correctly, or they just don't follow these rules, then what we're going to want to do is ignore this parenthesis as being a valid closing parenthesis, since it's not necessarily valid. So we're just going to want to either continue finding another closing bracket such that the parentheses within the brackets we found are valid, and if we never do find such a case, then we're just going to add the closing bracket ourselves, right? And so let's think about that again. So we have an opening parenthesis and we have a closing parenthesis. For each closing parenthesis we find, none of the substring within those parentheses is not valid. So if none of those are valid, then we know that this closing parenthesis is also not valid because it's not making str valid. So what we're going to want to do is just add the closing bracket ourselves if we never find a valid closing bracket. Never find a valid closing bracket. And this also goes for if there's just no closing bracket in general, right? So if we have, like, let's say for example, this first string where we just have an opening parenthesis, we're never going to find a closing parenthesis because this is just the entire string. So what we would do is just add the closing bracket ourselves, and now this is valid. So that was a bit of logic, and it was a bit much, but that's what we would have to do to make sure that this opening parenthesis is being closed properly. So now there's also the case. Let's just call this 2a. Now we have 2b, where string I is a closing bracket. And the logic here is basically analogous to what we would do if string I was an opening bracket. So we would find a corresponding opening bracket, and we would actually do this in the result string. So what I forgot to mention here is that we actually are initializing a result string, and that will just hold the new valid string. And then within the second step, we're iterating through the string, and then we're just going to rename these to 3a and 3b. So within 3a, we're just doing the same thing, right? If it's an opening bracket, then we do all of this in here. And we're actually going to find the closing bracket in str. And now within here, stri is a closing bracket, so we're going to want to find a corresponding opening bracket in result. And this makes sense because we're backtracking on our result and we're saying, okay, is there a parenthesis in here that is properly being closed by this closing bracket that we find? So if we never do find a closing bracket, then we're just going to add closing or opening bracket ourselves. And if we do find an opening bracket, then we're just going to do the exact same thing here. We're just going to make sure the brackets within the brackets that we found are closed correctly. And once again, just this last line, and make sure that the opening bracket, if it's not there, then we're just going to add it ourselves. And once we've done that, we've essentially handled all the cases within the string. So we're just going to return result for step 4. So we have this entire solution, and let's just go through it one more time. So first we initialize the string, then we iterate through the given string str, and there are 2 cases with each character. Either each case or each character is an opening bracket, and if it is, then we're going to find a corresponding closing bracket in str. If there's none found, then we're just going to add the corresponding closing bracket ourselves. Otherwise, if we do find a corresponding closing bracket, we're going to want to make sure that the string within the brackets that we just found are valid. And if they're not, then we're just going to keep finding a bracket until we satisfy either the condition that there's a substring within the brackets, or the substring that is within the brackets is valid and it follows all of these conditions, or if we run out of parentheses to find, then we just add the closing bracket ourselves. And we're essentially doing the same thing here with the closing bracket. We're just finding an opening parenthesis and making sure that these conditions are being followed. And if they're not, then we just add the opening parenthesis ourselves. So let's go through with some example 4 and just really make sure that this solution works before we do anything further. So we're given this string here, right? So we initialize some result, okay? So let's just call this str, and we're just going to have some result string. Iterate through str. So str I is an opening bracket. Clearly, yes, it is. So then we're going to want to find a corresponding closing bracket in str. So notice how there's no corresponding closing parenthesis. So like we said, if there's no corresponding closing parenthesis, then we're just going to add it ourselves. And then we iterate to the next character in str, and once again, there's no corresponding closing parenthesis. So we just add another closing parenthesis. And then we iterate to the next brace here, and we see, okay, it's a closing bracket. So we're going to want to find the corresponding opening bracket. And once again, there is no corresponding opening brace in here, so we just add it ourselves. And then again, we do this for the last bracket, and it does work. So we see that this seems to work for at least one of the cases. And if we think about it a bit more, this solution does seem to work actually, because like we said, we want to add the minimum number of correct brackets. And what this is doing is it's going through the entire string and it's checking if there is a set of invalid brackets. And whenever we do find an invalid bracket, well, we're only going to want to add one more bracket to make the string valid. So that's what we're doing. And we're never adding any brackets unnecessarily. So this solution does seem like it would work. Now, I'm not actually going to code the solution because there's actually a little bit of an optimization we can make. But first, I just want to note what the time complexity is and the space complexity before we move on to another solution, right? And you're allowed to do this. You don't have to necessarily code every single thing you think of. What I want you to do is just come up with a solution, write it out, either in some sort of pseudocode, or you can write it out in actual code if you'd like. But once you actually have a solid idea of what to do, I want you to be able to take away something from that solution and then optimize it further. And so that's what we're doing here. We're not explicitly writing it out, but we are going to take something away from this. So we want to start looking at the time complexity. And you might want to think, okay, well, what's the worst case for something like this, right? So the worst case is maybe we just have some string that looks like this, right? Where it's just a bunch of opening parentheses. And whenever we do find an opening parenthesis, we look through the entire string to find a closing bracket, and we never do. So we never do, and then we just add it right there. And then we go to the next character, we iterate through the entire string again. Again, there's no closing parentheses, so we just continue to do that. And we do that for every single brace, right? Every single bracket. And you might know from class that this sequence of doing n iterations, then n minus 1, n minus 2, all the way up until 1, that's actually a mathematical identity of n times n plus 1 over 2. So this seems as if we're doing some sort of n squared iterations. And as a matter of fact, yes, this is O of n squared at least in terms of time complexity, which is not the best, and n is actually just the length of the string itself. And the space complexity, of course, since all we're doing is just holding the length of the string, it's only going to be O of n, because at most the string will just be twice the length of the given string. And this makes sense because str, it can, in the worst case, either be just a bunch of opening brackets or closing brackets. And if it's either one of those, then we're just going to need to add all the corresponding brackets. So it'll be at most 2 times the length, and at least it'll just be the original length of the string, where the string is just a valid set of parentheses. So we just don't need to do anything for that. So we have this time and space complexity, and we see that it's quadratic in terms of the length of the string. Now, note that we didn't use any stacks and queues in this, and you might be wondering, well, this is the stacks and queues lesson, why haven't we done anything, right? Well, we're getting there. So you might think, how can we use a stack or a queue in this case to optimize either the time or the space complexity, right? Well, think about the previous question, which was checking if a string of parentheses was valid itself, right? So let's just write that out right now. So within here, we used a stack. So whenever we found an opening parenthesis, we just pushed that to the stack, right? Push to stack. And then when we found a closing parenthesis, there were several things we did, I think. We looked at the top of the stack, and if the top of the stack did not have the matching closing bracket, then we returned false, right? So there's also the case actually where the stack is just empty. So stack is empty, or top doesn't match the matching opening bracket, right? And in this case, that corresponds with either the closing bracket was never opened, which violates condition 3, or the brackets are just not being closed in the correct order, so 2. And then we would just return false. And there's also the third case, which is after we iterate through the entire string, where the stack is not empty after iteration. And if it's not empty after the iteration, then we know that there were some parentheses in the string that were never closed, which is a violation of the first condition. So within this solution, what we did was we identified what made a string invalid. Now, you'll remember within this problem, we want to find when the string is invalid. And then whenever we find when the string is invalid, we want to just add something to the string such that it becomes valid. So this solution of valid parentheses, right, it becomes very useful to us. So we're identifying whenever the string isn't valid. So whenever there's a closing parenthesis that isn't being opened, or it just doesn't have a corresponding one, then we know that it's invalid. So what we can do here is actually just add corresponding opening bracket, and then we wouldn't have this violation. And same for the stack. When we find that it's not empty after we iterate through the entire string, we're going to want to add the opening bracket. And so in this sense, what we're doing here is we're going through the string and we're saying, okay, well, this string isn't valid, but then we're kind of saying, well, what can make this string valid? And like we said, if the top doesn't match, or if there isn't one, then we add the corresponding bracket and we imagine that it is in the stack. And once we imagine that it is in the stack, then we know that the string itself is valid. And same thing here. If the stack wasn't empty, or the stack is empty because there were parentheses that didn't close it, well, then we're just adding the parentheses to this string so that they can all be properly closed. And from this solution here, we know that whenever we're finding some sort of invalid notion within the string, we're actually just adding as little brackets as possible, since we're only adding one, and we're also just not doing anything unnecessary. So it seems as if we are adding the minimum number of brackets. So let's just go through one quick example first, example 2, to make sure that this solution is actually valid, and we're not just going to code something that might not work. So string is just going to be this, and then we're just going to have our result string again. So whenever we encounter an opening parenthesis, we're going to want to push that to the stack, and then let's just also add that to the result as well. And then whenever we find a closing parenthesis, either the stack is empty or the top doesn't match and it's invalid. So we encounter this closing parenthesis and we see that the top of the stack just includes this opening brace. Now we know that this is invalid because the closing parenthesis for this opening parenthesis isn't what's on the top of the stack. So like we said, we just add the corresponding opening bracket and closing bracket to the result. Now we've finished iterating through all of the characters in string, and so we look back at what's actually on the stack, and we see that there is one little brace that is on the stack, and so that was not closed properly. So what we're going to want to do is just add it to the string itself. And as we see, that is actually one of the output for the example itself. So this solution does seem to work, and it also does make sense, like we said, because we explained our thought process and we're adding as little parentheses as possible to make the string valid. So now let's just go ahead and code the solution. So we're going to have our string called result right, and we're just going to make that empty at first, and let's just have the solution return the result. That makes sense. And then we're also going to be using a stack, so let's just include that at the top here, include stack, and we're just going to make our stack, and since it's going to be holding every single character of the string, we're just going to have it be a stack of chars, and we can just call that S. So we're now going to iterate through every single character in str. So for char C in str, so now that we are iterating through every single one, we're going to want to check the first condition. So if it's an opening parenthesis, right? So if it's an opening parenthesis, then we just push the character to the stack. So how do we check if it's an opening parenthesis? Well, we know that there are only 3 types of opening parentheses, right? So if it's that opening parenthesis, or if it's an opening brace, or if it's an opening bracket. So if it's either one of those, then like we said, we're just going to push that to the stack, and we're also going to want to add that to the result. Now the next condition is if it's a closing parenthesis, right? we know from the constraint that everything is either an opening or closing parenthesis, so we don't have to impose any extra condition. If it's not one of these, then we know that it's not an opening parenthesis. So within here, we're going to want to check if the stack is empty or if the top doesn't match the opening bracket, then we're going to want to add the corresponding opening bracket. So to do that, we actually need to know what kind of closing bracket we have. So if C is, let's just say, the closing parenthesis, we're going to want to check the top of the stack. So let's just go ahead and do that. First, we're going to want to check if the stack is empty, right? So if S is empty, and if it's not empty, well then let's look at the top. And if the top doesn't equal the corresponding opening bracket, then we see that there's a violation. So then we just go ahead and say result plus equals to, let's say, yeah. And since every single opening parenthesis is being pushed to the stack as well as being added to the string, all we need to do is just pop it off of the stack and add the closing parenthesis to the result itself. And then we can also just go ahead and do this if it's a closing brace as well as if it's a closing bracket. So before we continue on with adding these statements themselves, we're actually just going to create our own helper function that does this within it. So it takes in a closing parenthesis and it does this logic where it checks the top of the stack, and if the parenthesis isn't what we want, then we just add it ourselves, and we also do this other logic. Now the reason for this is it's also just good practice to not repeat your own code, and it would also see your interviewer would see, okay, this kid knows what he's doing, so let's just do that right now. We're going to take in the string result, right? Since we're modifying it, we're just going to take it in as a reference, and same for the stack, and it's going to be a stack of chars, yes. And then we're going to take the opening parenthesis and the closing parenthesis. And so here comes the part where we can just copy and paste this code right here. Let's just fix some of that indentation. And this is basically it. So we're just checking, okay, if the stack is empty or it's not equal to the character that we want, then we're just going to add the opening and the closing to it because the closing parenthesis was not being opened properly. Else we can just pop from the stack because the closing parenthesis is being opened properly, and then we just add the closing parenthesis. And this allows us to actually clean up our code, and it actually just makes it a lot nicer. So we can just go ahead and have the helper, the result, the stack, and then like we said, the opening and the closing parenthesis. And since we know that this logic works generally for the opening and closing, we can just copy and paste this now here and here, and just make sure that the braces are matching. And so that's basically our entire first loop where we check and make sure that each of the parentheses, whether it's opening or closing, is valid. And we actually have one more. Remember, our last one was if the stack is not empty after the first iteration, then we know that there are some opening parentheses within the stack that were never closed, since remember, we're only pushing the opening parentheses. So we're just going to do a while loop, and we're going to say, okay, while this stack is not empty, then while the stack is not empty, we go ahead and look at what the first, or what the top of the stack is, and we add that closing parenthesis to the result itself. So if s.top, let's say, is equal to the opening parenthesis, then we're just going to add the closing parenthesis. And we're just going to do the exact same thing. There's no difference when we do it with the brace or with the bracket. So else if s.top And that is basically our entire solution. You just have to remember to pop off the stack after each one of these iterations so that you don't go into an infinite loop. So yeah, let's look at this solution and see if it matches what we wanted before, right? So whenever we iterate through this, we see that we have an opening parenthesis. We push that to the stack, and we also just add it to the result itself. And then if it's not an opening parenthesis, then we know it's a closing parenthesis. So we go ahead and go into our helper function. If the stack is empty, or the top doesn't match the opening parenthesis that we want, then we know that it's invalid. So to make it valid again, we just add the opening and the closing parenthesis. Else, the string actually is valid, so all we have to do is just pop off the top and just add the closing parenthesis. And we do this again for the parenthesis, the brace, and the bracket. And once we've done that, all we're just going to check is if the stack itself is empty again. And remember, we said if it's not empty, then there are parentheses that aren't being closed, and we just close them ourselves and pop. So let's just look at this example again, example 4. And we're going to have str is just equal to this. And then we're just going to say our result is empty for now. So we initialize our result, we initialize our stack, and then we begin iterating through str. So we check, okay, is the str an open parenthesis? Yes, it is. So all we have to do is push that to the stack and add that to the result as well. So then we iterate again. Okay, we see another opening parenthesis, so we add that again to str. And then we go to our next iteration. We see this brace. Okay, it's not an opening parenthesis, so we don't execute anything in this statement. So now we go into this else statement, and we actually execute the first if statement. So we see that it's a closing parenthesis. Then we go into our helper function now, and we say, okay, is the stack empty? Clearly it's not, because we just added these two parentheses to it. So then this is false. But then we check the top of the stack, and we say, well, the top of the stack isn't corresponding to this opening parenthesis that we want here. So because of that, we're just going to add it ourselves. And so we're done with this helper function, and we go and iterate through our last character, which is just this closing brace. And we basically do the exact same thing we did in the previous iteration. We execute this here now. We see that it's a closing brace, so then we go to the helper function. Once again, the top of the stack doesn't match the opening bracket, so then we just add it ourselves. And so we're done with this first iteration, and now we go through the stack, and we see, okay, well, there are these parentheses that were never added, or that were never taken off of the stack. And so we go ahead and look at this statement, and we say, okay, well, the top of the stack is an opening parenthesis, so we just add the first closing parenthesis, then we pop it off of the stack, and we go to the next closing parenthesis, and we pop it off the stack. And now the stack itself is empty, and so we return this result, which does seem to be this result right here. So our solution does seem to work, and it makes sense, remember, because we planned it out logically. We said, okay, well, if it is invalid, then we're just going to make it valid. So this isn't too much of a surprise. So now what we're going to do is just test it against the rest of the test cases and see if it passes. And if it doesn't, then we're just going to fix some things. Oh, and look at that. It does pass all the test cases, so our solution does seem to, in fact, work. So before we do anything else, let's just take a look at the time complexity for this and see how much of an optimization we really gained over the original solution. So in terms of time complexity, we're doing this first for loop, and we're iterating through every single character of str. Now within this first for loop, all we're doing is pushing to a stack and adding a character to a string, which are both of one operations. And So we know that this entire if statement is just an O of 1 operation. It's constant. And if we look inside of this else statement, we go ahead and execute this helper function within each of these if statements here. And if we look at the helper function, actually, all we're doing is checking the top of the stack, adding to strings, either popping off of the stack or just adding again to a string. And all of those are actually just O of 1 operations. So with every single iteration of this loop, we're just doing an O of 1 operation. So this is actually O of n, since n is just the length of the string, and we're just iterating through every single character and doing just an O of 1 operation. Now we have this final for loop. So in the worst case, remember, since we're only pushing opening parentheses to this, there's a case where the entire string is just a bunch of opening parentheses. And in that case, then we're iterating through the entire string again. And if we look again at what's inside of this for loop or this while loop, we see we're only accessing the top element, concatenating to results, and then popping. And each of these are just O of 1 operations again. So we can conclude that this is just an O of n loop, where n is just the length of the string. So yeah, and everything else we're just declaring variables and then just returning result. So this seems as if the time complexity of this is just O of n plus n, which is just O of n. So we can immediately see that there's a big improvement in terms of the time complexity, whereas the previous solution had quadratic time complexity. It was n squared. This is actually just linear now, which is a big improvement. Clap your hands, give yourself a pat on the back. That was a good one. And then we look at the result now, or we look at the space complexity in terms of our algorithm, and we make the observation once again, we're holding this result string, and we noted in the previous solution that this is only ever going to be at least the length of string, or at most twice the length of the string. And now we have this stack, and like we said, in the worst case, we're just pushing every single character of str onto the stack. So this is only ever going to hold at most n elements. So this is going to hold, at least it's going to grow O of n, and so is the results. And so like the time complexity, this is just O of n plus n, or just O of n. So what I really want you to take away from this example is not just how much we improved the time and space complexity with the solution, but how you can use stacks and queues within these sort of interview questions, and how you can actually gain pretty significant improvements in sort of time and space, or just time or space. So yeah, whenever you're facing some sort of interview question that seems as if it's inefficient, you might want to think of some data structures that might be able to optimize your solution, right? Within this original solution, we weren't really like taking advantage of any data structures. We were just looping through the string itself and checking, which allowed us to have some pretty big time complexity. But within here, we were able to take advantage of a stack, and we reduced it to O of n. So that's all I have for you all today. Thank you for watching, and have a great day.